Again, the same program is available. It's uploaded on a Google Classroom as well as in MS Team. In that case, token I have written only star 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 there, because you have to open your own UB.S account and then you have to write your own token. This token and all that. So now program is being uploaded. It has already compiled, and now the process of uploading is taking place. Let me switch on my camera again so that I can show you that. If you can see here, my sensor is available here. This is a small digital I/O board which has a 2 preset, 1 buzzer. Is it visible to all of you? Praptiman, can you just give me feedback whether it is visible or not?
Yes, sir, it is visible.
So there are 8 LEDs on the board. Here connectors is given for the LED. 4 switches are there. 1 bus is there. Then 1 LDR is there. So at present we are going to utilize this LDR. 2 preset is there to simulate any analog sensor. Presets are given. LM35 temperature sensor is there. IR sensor is there. So this small digital I/O board you can use to teach your students. You will be able to easily perform to 10 experiment on this. This type of a smaller digital I/O board. So we will be using LDR. Now suppose I put finger on the LDR. This screen is visible to you. I can see here this analog sensor output it is showing on UB.S. 964 it is showing. On the mobile phone also I have the same GUI available. Same UB.S. So ultimately I am uploading this LDR data, and the cloud I am fetching that data and displaying on the local screen, right? On the mobile screen as well as on the desktop screen. If I remove the finger, then light will fall on the LDR, voltage will reduce, and that's why you can see here the output. And here, my finger, you can see the LED will turn on. LED should turn on if it is okay. I have not done connected the LED. I will connect the LED first, and then I will show you. So first of all, let me check in which pin I have connected the LED, and then I will. LED pin 2 and red 5. So I will be connecting my LED with 5 number 05, that is a D1. So with a D1 pin I will connect my LED. So this is my node MCU board, and this is my red. I will connect it with a D1 pin. So D1 pin is here, so I will connect it here. Okay. Now if I will put my finger on this LDR, LED will turn on. That means is automatic street light operation. If there is a dark condition, no light on the LDR, the street light will turn on. And whenever there is a daylight is there, the light will become off automatically. So not only this is controlling this LED locally or street light locally, but it is also sending data to the cloud, set at which time the light was on and at which time the light was off. Because here we are using here a UB.S cloud, so it is also sending the data simultaneously to the cloud. Now I will show you in a UB.S actually how to get the API. So you have to open your account in a UB.S. I have already given the URL in my presentation. From here you will get your API. Here API credentials are there. Then you have to you can show this token here. So this token you have to copy from here and you have to paste this token in your program, right? So intentionally, whatever the program I have said, I have not written this token there. Otherwise, all of you will upload data on my ub.cloud, right? In my account. I don't want that, so that you open your own ub.account account and then you use your own token. So just you copy and paste your token here. Just you change this Wi-Fi SSID and password, and the same program will work for you. And later on, you can play with this program. You can do necessary modifications in this program and develop your own program. Then inside this, actually, there are actually, this is actually a dashboard. So under this data section, you will find the different dashboard. So I have two dashboard now. One is the analog sensor, and second one I am going to show you is a DHT sensor. So DHT sensor will give us the humidity and temperature both. And I will also show you these devices. What are the devices available with me, and how you can add the devices later. So now okay, again, madam, I will disturb you again and again, but let me check whether it is, light, temperature, humidity, everything is visible or not.
Yes, sir, it is visible. All the three
Okay.
quantities.
So you can see that light data is visible. Okay. Light a few seconds ago, just, we are continuously transmitting the light data, so it is coming continuously here. Temperature and humidity, just I checked 2 hours before when Thakur's lecture was going on and I tested my setup. So at that time I have uploaded it. Now again we will upload it so that it will come, latest data will be available here. Okay. So these are the devices. Later on you can also add the more number of devices here using this plus sign. You can add devices from here. And in a dashboard also you can increase the number of widgets required. So this is one widget is given here. Suppose if you want to add another widget, you can just click on this plus sign and select whatever the widget you require. Right? Suppose if you require a kind of a widget like a tank, you can select a tank. Then this tank you have to map with some variables. So there are so many variables available. At present we have connected LDR, so I will be selecting light variable. I will select this light. So this actually, cloud symbol is shown here. So this light data will come to cloud from that sensor and will be available here. So that light variable we are mapping. And in this tank widget, I can say that it is my light intensity. So I can write light. And the highest value would be 1023 because we are using 10-bit. So 10-bit ADC will provide minimum value 0 and maximum value 1023 because it is 2:10. So total 1024 values you will get. So just when I click on that button, that widget will be available to us. At present 557 is the reading here, as well as 530 is reading here. So both readings are same because light intensities are now varying. If I put my finger on the LDR, the value will increase. So for a perfect darkness condition, you should get 1023, and for light condition, the value should reduce. Now I will switch on my torch in the mobile phone and throw light on the this LDR, and then the value will further reduce. So just I have switched on the my torch, and then the light will fall on the LDR, and the further, as you can see, the values are decreasing. Now it has become about 140. When I will remove the light, the intensity will now start increasing. Now you can see the intensities are increasing. You can also set the events here. Based on this data, you will be able to set the events. That means you will be able to send the email, you will be able to send the SMS. Whenever the light values are greater than certain threshold, you want to send email, then you can create the events here. Right? So you can see that select variable, which variable you want to select. Let's say light variable. I am selecting light variable. When the value of this light variable is greater than 800, and the same value will remain for 1 minute, then I want to create the action. Then you can also use some different logical combination, and an or combination. If you have more than one sensors, you can create all these logical combinations here. Then whatever the actions you want to take, so you will be adding the new action. What you want to do, you want to send the email, you want to send SMS, just you want to make a call. So these are the different actions. So let me say that send email. It will give this subject alert. It will give this message to the receiving party, right? You can also write different email here. And then just we can select it in this way. So now variable alert has been already set with help of it, and you can trigger multiple events with this type of settings. So this is what we can say event generation based on the data. So now this could be one of your exercise for you, that design a node MCU based system so that it detects the light inside the cupboard or a room and alert a person by email, SMS or a web application. So now suppose if you are outside your home and you fit this entire system in your cupboard, and whenever there is a dark condition, it should send you email automatically. So you can design such type of system using this UB.cloud or cloud. There are so many clouds are there. You can use any cloud. Firebase cloud is also there from the Google. Maybe today or tomorrow afternoon session we will discuss the ThinkSpeak cloud also. So we will be able to upload the data in a ThinkSpeak cloud also. So this is one typical exercise. It's already there in the presentation. You can try yourself. So to do this exercise, what you require, you have to connect LDR with your node MCU. Some of you have already connected the LDR because I have seen in WhatsApp group that some of you were asking the specification of LDR. So if you have LDR, you can connect with A0 pin. Just copy and paste my program there. Change your SSID password, change your token, and then do this experiment. And you can send a message like somebody has opened the door of cupboard by email or by SMS. So all of you are requested, those who are having a node MCU board and those who are having LDR with you are requested to perform this exercise at home. Now I will show you this DTH sensor, which is actually a digital humidity and temperature sensor. The previous sensor was analog in nature. It was giving us analog data, but this sensor is giving digital data. It's not giving us analog data. Right? So I will show you the demonstration of DHT sensor, and then after we will have a question answer followed by this. Right? So I will use now DHT sensor instead of the simple analog sensor. So I will show you that program in an Arduino platform. Just look at this connection. This DHT sensor has only 4 pins. 1, 2, 3, 4. Number 1 is VCC. That means we have to connect 3.3 volt here. 2 is data. So this data pin we will connect with the node MCU, GPIO2 or any other pin. And this 4 is a ground. So simply 3 wire you will require to connect this sensor with your node MCU. I will show you that program. Send DHT to UB. This program I have applied on the Google Classroom as well as on the Microsoft Team. Prapti madam, again, sorry to disturb. Am I audible? Am I
Yes, sir.
visible? Everything
Yes, sir.
fine? Yes.
Yes, sir.
Fine, fine. Good. All right. So here DHT pin number 14, that means GPIO 14. So let me connect my DHT sensor with pin number GPIO 14, that is D5. Okay, I will turn on the camera also simultaneously so that I can show you. Okay, this is my DHT sensor. It's visible to all of you. Three wires are there: red wire, then data wire, and black wire. The red wire is connected to
It is
VCC, black wire is
visible, sir.
connected to visible. Thank you very much. And this data wire is connected to D5 pin, that is our GPIO 14 pin. I will upload this program here. The connection is over. Simply have to connect only, so connection doesn't require much time. Now it is compiling this sketch and try to upload this into the Node MCU board. So every time whenever you change the program, you have to upload it again into the board. And I will be using the same token here. So I will be using the same my cloud to upload this program. The same Wi-Fi and password I am using here. Yesterday, somebody was asking that, how, IoT will come from where the data is. So that is actually with help of a token. So, every user has a different token. Every device is having a different API. So using that, actually, this is a kind of it also provides a security, right? If you have a token, then only you will be able to send the data. If you have a token, then only you will be able to read the data, right? So now I think it has done. It is also locally displaying, we are using here serial.print payload. So whatever the data we are sending, this is also available locally here. So at present temperature in Rajkot is at 28 degrees centigrade and humidity is around 39. So it is measuring that both the parameters, and it is at present it is uploading on the cloud. So now let us go to the cloud. In the UB I have another actually this data will. So you can connect more than one device. You can prepare more than one dashboard in a UBDOS. This is our analog sensor, and now I will switch over to the different dashboard. This is another dashboard, my control panel. Now you can see that DHT sensor data is available here, 28.4 degrees centigrade temperature and 39.3 is a humidity. And I am getting here graph also with respect to time and date. I will be able to observe the variations in the humidity as well as in the temperature. Again, I will try to show you in my mobile phone also. On this application in my phone. So you can select any type of widgets here. So you can just click on here and you will be able to select the widgets here. Now whatever the widgets you will select will be also available on the mobile phone. Here you can see here that one gauge is there which is showing temperature 28.3, humidity is 39, and below that there is a graph, right? In a graph, both the parameters are simultaneously shown in a one graph. Humidity as well as temperature both are shown in the single graph. So this is how you will be able to send the temperature, humidity data, or any sensor data you will be able to upload in a UBDOS. I think I should stop here because there must be some gap for the question answer session. So if you have any doubt, any questions, you are free to ask. Afternoon session is also dedicated for this. Professor N.B. Kalani will discuss this MQTT protocol in more detail, and our Professor Puneet Lathia will show you some more demonstrations, right? So at present, I will stop here my presentation, and if you have any doubt, any questions, you can ask. I will stop screen sharing here. Prapti madam, if there are questions in a chat section, you can also read, or otherwise I will also read and will try to give the answers.
Yes, sir. Sure, sure. Sir, board name is asked by some of the participants. Which board is being used?
Okay, at present I am using Node MCU board, which is easily available with a 250 rupees or a 300 rupees cost. And I have sent the link from where you have to purchase this. That link was shared to you in a WhatsApp group. I will also put that link on our Google Classroom so that you will be able to purchase it. If you want to do some experiments, right, then you will be able to purchase it. Any further questions?
The platform is asked. Which platform is used to design mobile app?
Used to design app. Actually, I am using MIT App Inventor because it is good for electronics engineers. Because I am not from computer engineering branch. But Prashant Mehta will, share in his session. He is using Android Studio. But whatever the application which I have shown to you, that I am using MIT App Inventor. So basically, that's a good. It's providing us a graphical programming. It's very easy for us to design app with help of that. So that platform is good for, again, good for a non-computer engineer. That means for electrical, electronics, and other discipline. The sensor board name is Digital Analog Input Output Board. DAIO. It's a DAI. Digital Analog Input Output Board. Because it has a digital input as well as analog input. It has also digital output. So it's called Digital Analog Input Output Board. One more question I can see here is, sir, is there any setting required while uploading a code like upload speed, CPU, frequency? No, actually Arduino is very nice. It is doing all the setting itself. Whenever we use the AVR Studio and all that, we require all such kind of a setting. But Arduino is a very good because whenever you select the board, automatically it will detect the board, and it will also has a database that what is the CPU inside that board, what is the speed of that CPU, everything is there. So for that actually you don't require. If you select the proper board, then you don't require to do any other settings. Please show last 2-3 program again. Oh, okay, it is already uploaded there on the Google Classroom as well as MS Team. You can download and you can see. And this entire lecture was recorded on a YouTube. So you will be able to download the recorded session. And all our yesterday's recorded session, I have already placed that in a Google Classroom. I will show you that Google Classroom because I could not see more participants there. I will share my screen again and will show you that Google Classroom there. Just tell me whether my screen is available or not. Let me open the Google Classroom. This is visible, ATAL FDP on Internet of Things, this Google Classroom.
Yes, sir.
Okay, so inside the classwork, all the laboratory resources you will find. Then YouTube links for all the sessions. So all yesterday's sessions are placed here. Today's session we will put it by evening. These are the PPTs shared by the experts for day 1, and this is for day 2. Similarly for day 3, 4, 5, everything will be available here. And if I display these people here, let me see how many people are there. 34 are there. Approximately there are 87 participants are there. So those who have not joined the Google Classroom, please join it again. I have already shared this class code on your WhatsApp group, as well as on a team, as well as on, it was many times communicated to you through the chat section during our morning lecture. So this is the class code. I will just make it big font so that it is visible to all of you. Just you can write this class code and join the Google Classroom. With help of this code, it will be easy for you to find all the materials related to the FDP. And all these materials are also uploaded in a team. As you can see here, I will show you that team here. In this ATAL team, you can find the file section. And inside this file section, you will find all these materials are available here, which you can easily refer here from. If participants are having any doubt, please ask. Otherwise, I think we will end this meeting here. If you have any doubt regarding, pre-test or material or your attendance or whatever, if you have any doubt, you can ask. I will download your attendance also.
Okay.
Every day I am downloading the attendance twice in one session. At the start of the session, after 5-10 minutes, then in between or at last. So randomly I am downloading attendance twice in a session. And based on that, your attendance will be calculated. I think, Prapti Madam, I think there are further no more questions. So should we end this meeting here?
No, sir. Yes. Thank you very much, sir, for your valuable hands-on session.
I think one more question I got in the chat box from Said.